All right, so enough talking about it. Let's go and actually fit our model in R, remembering that our first X is grants, our outcome is salary, our first dummy is that one about associate, the second then is associate, and there will be some estimated error as well. We can do that in R with our LM function. Again, we are using an additive model, so we're just adding our first and second dummy variables for assistant and associate. We can then see the regression output with the estimated coefficients in model 2, the explained variation of these three variables of variation in our outcome salary is much higher than just having grants, which would make sense. But I do think it's notable that there is more explained variation by the variation in rank than there is by the amount of grants that they get. So that is interesting, though that's not necessarily the intention with what we're doing here. We want to interpret the fitted line now for each of the different ranks and run some hypothesis tests with regard to whether or not the effect is different for rank holding grants constant. So what do we need to do to separate the models in order for us to have a fitted line for each level of rank for associate, assistant, and full? So we'll start with assistant, and that's, again, including our intercept as well as grants and, I'll wait, our first dummy, right? Just the first dummy. The second will be associate. That'll be our intercept plus the beta and value for grants plus our second dummy, not the second. Or sorry, not the second beta and the first dummy, the third beta and the second dummy. Then for full, we just have our intercept and our beta as well as the value for grants. Neither of the dummies, right? Now, all we need to do is take the estimated coefficients from our regression table and plug them in order to get the fitted model. So we can start with assistant, where again our intercept is about 90,000 minus 27,000 plus 0.003 xi. And again, the xi is for the grants, right? The estimated coefficient for D1 is the negative 27. So again, if we were looking at the difference, what that's telling you, right, is that between assistant professors and full, remember that's the baseline, they on average, holding grants constant, make around 27,000 less. Now we can do the same for associate, and the only thing that's going to change, right, is the estimate of the relationship difference between associate and full, right? So we can interpret that as associates on average holding grants constant make about $20,000 less than full professors. And again, we then include the estimated beta relationship between grants holding rank constant. Full is just going to be the y-intercept plus that beta for the estimated relationship between grants and the outcome. We can then go ahead and actually look at these fitted models graphically quite easily in R. Now, there's a lot of code on here. The only thing that is really essential here is that I am putting the dots and differentiating them by color for rank. That's all I'm doing here from lines 1 through 4. Then when we get to 5, I'm just taking out the estimated coefficients from our regression, and from line 6 through 8, I'm creating 3 separate regression lines using the coefficients for associate, assistant, and then for full, there would be no coefficients, right? It would just be the intercept beta naught plus the estimated coefficient for grants times the value of x, right? And so at the end, I'm just plotting a legend so that you can distinguish between the three lines. So you'll get something that looks like this, where you can see assistant professors on average are making the lowest amount, associates are making the middle, and full are making the most. What you can also see by this is that there really isn't much of a relationship between grants and salary, right? It doesn't seem that increasing the amount of grants that you get has much of a discernible impact on your projected salary. But the real question here is whether or not we should be distinguishing between rank, i.e., are these different lines different from each other in the sense of where they cross the y-intercept, right? Because we're not comparing differences of slopes. We're not assuming that there's a different effect of grant by rank on salary. So we need to conduct some hypothesis test. Now, how do we test if rank is useful in the model at all? Well, we can do a partial f-test and say, is the impact of assistant equal to the impact of associate? And is that equal to 0, right? Essentially, is there no relationship between rank and salary? Therefore, our alternate would be that there is some relationship between rank. We're not saying whether it's assistant or associate. We're just, or full. We're just saying some value of rank has an impact on salary. And we can do that, again, using a partial f-test where we have the full model with all of the dummy variables, and then we have a subsetted model which excludes the dummy variables. Then, when we get the results of our ANOVA or analysis of variance, we get a large f-statistic around 157, which results in a very low p-value, which would suggest that rank does have some discernible impact on salary, holding grants constant. To sum up what we talked about today, we first discussed how to create dummy variables that are binary. We then talked about how to create multi-categorical dummy variables. We then went over how to construct the regression line and the fitted line. We then talked about how to execute that in R as well as how to interpret that. Today, all we talked about though was additive models, right? Whether or not there was the same effect for rank, but by different levels, right? We did not assume that there were differing effects of grants based on whether or not you were an assistant or an associate professor, right? We assumed that the effect of grants was constant across the categories, and we were just trying to discern whether or not rank was an important variable to include, not whether or not there was a differential effect of grants by rank. And that's what we're going to go over next time.